Okay, so here are the notes for 9.1. So the first thing we're going to talk about, we're going to talk about compound inequalities. So inequalities, first of all, mean that you're talking about these symbols. Otherwise, it would be an equation. And we're going to be talking about two different types of compound inequalities, and statements and or statements. But before we do that, let's talk about finding the intersection of two sets. Intersection means where the sets overlap. The intersection is where they overlap. So if we look at the set of numbers A, 1, 3, 5, 9, and the set of numbers B, this symbol right here means intersection. So if I want to take A intersect set B, that means I want to know what values do they have in common, or where do they overlap. And you can see they're going to overlap in the values of 3 and of 9. That is the intersection. So now, how does that translate into inequalities? Well, whenever you are solving a compound inequality that is an and statement, the solution set is the intersection of the two sets above. So a nice way to look at it is by using number lines. So that's what I'm going to do here. So these first two number lines are for my two inequalities. And then my last number line is going to be the intersection. So if I want to first graph all the values less than or equal to 5, so we don't have to go crazy with this number line. So here's 5. Less than or equal to 5. Now remember interval notation. That means you're going to have a bracket and an arrow going to the left. Those are all the values less than or equal to 5. Remember, parentheses is where it's just less than. This is inclusive. It means it includes the positive 5. And now if I want the solution, or the set x greater than or equal to -3, well, if this is -3 and I want all values greater or equal to, again, I would have a bracket, and then I would have all of the numbers to the right, greater than or equal to. So if I want to know what values are both less than or equal to 5 and greater than or equal to 3, I take the intersection of these two sets. Well, that would be simply where the two sets overlap, which would be all numbers from -3 up until +5. This would be the solution set. These are all of the numbers that are both less than or equal to 5 and greater than or equal to 3. So there's a graph of the solution. If I wanted to write the solution in interval notation, it would simply look like this. And I believe they're going to ask you for both the graph and the solution set. All right, now some weird things can happen. Let's go ahead and let's look at this example. So the first thing we have to do is simply go ahead and solve each one of these individually. So you can see here I just subtract 5. So I'd get x is less than 4. And here I'd add the 1 and divide by 3. So here is my solution. I want all values that are less than 4 and less than 1. Well, let's look at that with the 3 graphs again. Now, this is an unusual situation. I would say 85.8% of the time when you have an and statement, you're going to end up with your symbols and an in between for an intersection, because that's usually how intersections work. That's not going to happen here. So let's see. Let's go ahead and let's graph each one of these. So if I want x less than 4, I would have, first of all, a parenthesis because it's not less than or equal to 4, and I would have this arrow going to the left. There's a picture of all of the numbers less than 4. If I want all the numbers less than 1, again, I'd have a parenthesis, and I'd have an arrow going to the left. So see how these arrows are not going in opposite directions. They're going in the same directions. But again, because it's an and, my solution would be everywhere the two graphs overlap. Where do these two graphs overlap? Well, do they overlap here? No. Do they overlap here? No. They overlap everything from 1 and below. So that is a picture of all of the values that are both less than 4 and at the same time less than 1. How would I write that in interval notation? Well, remember interval notation, and I'm writing this set in interval notation. You always start from the left and go to the right. What's down here? Negative infinity. So your solution would be all numbers from negative infinity up to 1. And that would be what the solution would be like in interval notation. All right, let's do this one. This is again an and. So if I go ahead and if I were to solve these each individually, well, if I divide by 7, I'm going to get 0. Here, I'd subtract the 4 and divide by 2. So my solution set would be everything greater than or equal to 0 and at the same time less than or equal to negative 1. Let's see what this would look like. Well, if I do my 3 graphs, and you don't have to do 3 graphs, by the way, I just think it's a good visual to see exactly what's going on. So, what are the numbers that are greater than or equal to 0? That would be a bracket and all of the numbers to the right. How about less than or equal to negative 1? That would be a bracket here and an arrow going to the left. It's still an and. I'm still looking for the intersection, which means, again, where these two graphs overlap. Well, where do these two graphs overlap? They don't, do they? They do not overlap at all. So the answer to this one is no solution. And if you think about it logically, there are no numbers that are both at the same time bigger than 0 and less than negative 1. They can't be, because these are all the positives and these are negatives. They don't overlap. All right, our last and statement here. Now I know the word and isn't here, okay, but this is still considered an and statement. What it says is x over 2 minus 1 is both greater than or equal to negative 3 and less than or equal to 2. So this is still an and statement, even though our word and is not there. So I need to get the x alone. So what am I going to do first to get the x alone? I'm going to add 1, but I have to add 1 to all 3 parts. So that's going to give me negative 2 is less than or equal to x over 2, which is less than or equal to 3. Now, what am I going to do to get the x alone? Well, right now it's being divided by 2, so what do I have to do? I have to take and I have to multiply everything through by 2. So times 2, and times 2. So now it's going to say negative 4 is less than or equal to, the 2's cancel, and I have x is less than or equal to 6. So this is my solution. The solution is all values that are between negative 4 and 6. Those would be all values less than or equal to negative 6 and at the same time greater than or equal to negative 4. So if I wanted to graph that, I would use brackets because of the equal to. That would be my solution set. And then, of course, in interval notation, that would simply be all values from -4 to +6. And again, most of the time, this is how an and statement will turn out, but there are different situations like we saw in the previous two examples. Don't have to do the 3 graphs, but it may help you. Okay, I'm just kind of seeing if I should stop the video. No, I think we can fit these two on the video. Okay, so now we've talked about the and statement. Now let's talk about the or statement, which is our other type of compound inequality. But before we talk about or, we have to talk about union. Union means to unite. You combine the two sets. And the symbol for union is this. It looks like U. So if I want to take set A and unite it with set B, that means I want everything from both sets combined into this one set. So for example, and I'm just going to kind of do it from smallest to largest, I would need a -1. I would need a +1. I would need a 3. Now I'm not going to write it twice. I just need a 3. I need a 4. I need a 5. And I need a 9. These are all of the values that are in these sets when I combine them. Not the intersection, not where they overlap, but it's the union. And whenever you have an or statement, you need to take the union of the two sets. It's very different than when you have an and statement. So we have 3 of these, so let's go ahead. And again, I'm going to do the 3 graphs. So if I want to unite or find all the values, and I'm going to kind of do my 3 graphs up here. So I want everything, if I just graph them individually, less than or equal to 1. There's my 1. And that would be that set of numbers right there. And then I want greater than or equal to 3. There's my 3. So that would be that set of numbers. Now, again, I don't want where they overlap. I want to unite both of these graphs onto one graph. Well, if I unite both of these graphs onto one graph, put it all together, you can see that that's what my graph is going to look like. It would be all numbers except for the numbers between 1 and 3. So what would that look like in interval notation? Well, I'm doing this set in interval notation, so it would be all values from -∞ to 1, and then you would put a little u for united with all values from 3 to +∞. And again, most of the time when you have an or statement or a union, your second or your last graph will look like this. It'll be symbols and arrows going in opposite directions. Most of the time. That isn't always true though. Right, so we have 2 more quick examples here. So here's another or. So we know in the end we're going to have to take the union. So let's solve these. First I would add 2 and divide by 3. And here, if I want to solve this, I'm simply going to add 6. So here's basically what I'm looking at. So I want all numbers that are greater than or equal to 4 or less than or equal to 2. So if I do the 3 graphs, all numbers greater than or equal to 4 would be a bracket to the right. Less than or equal to 2 would be a bracket and to the left. So you can see this is going to be a pretty standard one. My solution, or if I were to unite these two graphs onto my bottom graph, you can see that it would be all values from negative infinity to 2, union with all values from, oops, I need a bracket here. Let's not mess up my interval notation because of the equal to signs, 4 to infinity. And there's my solution in interval notation. Okay, our last example is again an OR. Now this is going to bring up something you may have forgotten. If I go ahead and if I solve this inequality, I'd first add 5. Do you remember the fact that when you're dealing with inequalities, if you multiply or divide both sides of an inequality by a negative number, the sign changes direction? Does everybody remember that? So this final answer would be x is greater than negative 1. Or, now this one is simple. If I divide by 6, I'm dividing by a positive 6. So that's going to be x is less than 0. So I want all values that are greater than negative 1 or less than 0. Let's see what that's going to look like. I think this is going to be an anomaly, a different one. So let's see. I need, there's my 0. I like to have 0 on all my number lines. So if I do negative 1, that's going to be a parentheses, arrow to the right. If I do less than 0, that's going to be a parentheses to the left. So now look, now remember this is an OR, so we don't want to overlap. We want to unite everything on one graph. Well, if I take all numbers bigger than negative 1, let's say I put them in a hat, and then in that same hat, so that would be all numbers up to positive infinity. In that same hat, if I put all values from 0 down into negative infinity, and I put them all in the same hat, do you see where I am going to have everything? If I unite these two graphs, everything is going to be covered, which means my solution would be all real numbers, which looks like this in interval notation. And there's the end of 9-1.